Hi everyone, welcome to my channel. In today's video, I'll be talking about the mass and the volume relationship. So we have example here, we have two examples here. So let's take a look of the first example. The first example says that the number of hydrogen ion in 9.8 gram of tetraoxovate-6 solution is able to find the number of hydrogen ion that we can get in tetraoxovate-6 ion. This is kind of the example under the mass and volume relationship in chemistry. So the first thing you need to do is that you have to write the equation. So solution. So let's copy the chemical reaction because we are to find the hydrogen ion. So we have 2SO4, that is from the tetraoxovate-6 acid. So it will dissociate into hydrogen plus SO4 2 minus. So we are going to add 2 here in order for us to balance the reaction. After that, we are going to have 2 mole of hydrogen ion here, 1 mole of H2SO4 and 1 mole of SO4. So we are looking for 2 mole of hydrogen ion. So we should calculate the number of hydrogen ion, So now from the formula we have mole to be equal to number of atom upon the Avogadro's constant, which is 6.02 multiplied by 10 raised to the power 23. So, and we are given the mass of hydrogen, mass of tetraoxovate-6, as mass of hydrogen ion, that is 9.8 gram of tetraoxovate-6. So, mass of H2SO4 will be 9.8 gram, and the molar mass. So, let's find the molar mass of H2SO4 also. So, we are going to have H2 plus x plus O4. So it's going to give us 1 times 2 plus 32 plus 16 multiplied by 4. So it's going to give us 32 plus 16 times 4. That's going to give us 98. So 98 gram per mole. So after that, we can now go ahead and solve for the mole of H2SO4. So mole will now be equal to mass upon molar mass. We have a mass of 9.8 divided by 98. So our answer here is going to be 0.1 mole. And recall that we should calculate the number of hydrogen ion. So from the hydrogen ion that we have 2 mole of hydrogen ion. So we are going to have 2 multiplied by 0.1 because we have 0.1 mole here. So it's going to be 0.2 mole of hydrogen ion that we have here now. 0.2 mole of hydrogen ion. So now from our formula we have mole to be equal to number of atom upon the Avogadro's constant 6.02 times 10 raised to the power of 23. If I should make the number of atoms as a subject of the formula, we are going to have mole multiplied by 6.02 times 10 raised to the power 23. So our mole is 0.2. So multiply by 6.02 times 10 raised to the power 23. So we are going to have 1.2, yes, 1.20 for times 10 raised to the power 23 atoms. So this is the number of hydrogen ion that we can get in 9.3 gram. So let's take a look of the second example. So the second example goes like this. What mass of SO2 contain in the same number of molecules as 0.8 gram of SO4. Remember, they said we should calculate for the mass of the SO2, but we are only given the mass of CH4. So, solution. So, the mass of XO2 is unknown. We are calculating for the mass of SO2, but we are given the mass of CH4 to be equal to 0.8 gram. And remember, for you to calculate for the mass, you need to know this formula often, which is mole equal to mass upon the molar mass. So we are going to be using the mole of mass of CH4 that we get here to calculate the mass of the SO4. So let's go ahead. So we are going to have mole to be equal to mass upon molar mass. So the mole of the mass of CH4 that we have mole mass of CH4 is 0.8. So the molar mass of CH4, that's carbon plus H4, is going to be 0.8. Carbon is 12, right? Plus 1 multiplied by 4. So mole will be equal to 0.8 divided by, that's going to be 0.8 divided by 16. So you're going to have 0.05 mole. So after we have gotten that, we now come back to this formula now. So we have gotten the mole, which is 0.05 mole. So we now put the 0.05 mole here, our mass, which is the unknown, and the molar mass of the SO2. So X plus O2. Make the mass size with the formula. You're going to have 0.05 multiplied by, in the bracket of sulfur is 32 plus 16 multiplied by 2. The molar mass of sulfur is 32. So mass will now be equal to 0.05 multiplied by, okay, this one will give me 64. Let me multiply that. So 32 plus, okay, 16 multiplied by 2 plus 32 give us 64 multiplied by 0.05. So the mass of this will now be equal to 0.05 multiplied by 64. So it will give me 3.2 gram of SO2. So this is how we are going to be approaching all this kind of question. Anytime you come across this kind of question under the stoichiometry reaction. So don't forget to like, comment, and subscribe to my YouTube channel if you are new here. So thank you very much.